Yes.
So good evening and welcome to this session of Geotechnical Engineering 1, and with me is the team of my teaching assistants. They are my PhD scholars. Vijit, he is working in the area of gas hydrates, that is the multi-phase geomechanics, much more improvised version of soil mechanics which you are studying right now, or geotechnical engineering which you are studying right now. There you are studying the very simplified model, but he is talking about a multi-phase system. All right, you will come to know about what it is. Then I have with me Mr. R.S. Reddy, R. Srinivas Rao Reddy. So he is also doing his PhD on a very advanced topic, which is replacement of methane from hydrates by using CO2. I'm sure you must be studying in national network news that everybody is very concerned about the rising concentration of CO2 in the atmosphere. So Mr. Reddy's thesis is talking about, dealing with how to sequester, how to capture, how to store CO2 in the subsurface, in the soil mass. And I have with me Mr. Goli. His PhD thesis is again on uh, a sort of a multi-phase geomechanics, but mostly dealing with the utilization of waste material from municipal solid landfills and the industrial byproducts which are being discharged by the industries. So he is creating composites of different types by using this material. Then I have with me Mr. Kamran. So Kamran is also pursuing his research in the area of CCU, carbon capture and utilization and storage. So CCUS. And he is trying to utilize carbon dioxide to alter the basic characteristics of geomaterials, which are being disposed of from the industry. So you must be realizing that these PhDs are quite intricate topics and being pursued by the humans who have mastered simple geomechanics or soil mechanics or geotechnical engineering, and then they have come to this stage. Then my another PhD scholar is Mr. Prathvendra Singh, and Prathvendra Singh is dealing with another contemporary topic, how to utilize the rubber waste or the waste rubber as a sustainable infrastructure development material. And then I have Fakra Mir Rashid, and she is dealing with a very intricate topic again, which is geothermal energy and its extraction. So for all of you who have registered this course, this is the future of your expertise, or this is the future, like you can also become a part of such teams anywhere in the world, in India, alright, because these are topics which are very contemporary. So I brought them intentionally over here to give you an idea about what could be the applications of geotechnical engineering 1. Gone are the days when people just used to, mug up the course without realizing what its applications would be, whether industry would be ready to support your research or not. So most of them are sponsored by the industries, Indian industry, and Indian industry is very particular about the contemporary issues and how to come out with a solution. So I will request very quickly for each one of them to say a few words, and then we will start taking up the questions. All right? Vijay, please.
Good evening all. Welcome to this first session of Geotechnical Engineering 1. As Professor mentioned, I am Vijit. I work on multi-phase soil mechanics and different phases which I consider in the soil mass are ice, gas hydrates, or methane gas and CO2 gas. Conventionally, in geotechnical engineering, we most of the time idealizes that at the pores there will be only air or water. But in several practical situations, like in the case of frozen soils as well as in the case of hydrate bearing sediments, there will be ice, there can be hydrates, and there can be several other gases. So one need to understand how the soil behaves when the different phases present, as in the case of the flow properties, the strength, stiffness of the soil, which you will be learning in the second part of the course. But first of all, first we have to understand what are the different phases present in the soil and how they are going to influence the soil properties. So this is what I am into when ice or hydrates are present in the soil mass at the voids, how the strength are changing. Just for a quick example, you can imagine, say you have soil which is having some amount of water content. You can imagine that it will be kind of spongy, it will be having very less strength. But when you keep it in fridge and freeze it, it will become a brittle material. Its strength and its entire mechanical properties are going to change. So we are quantifying it through my study. Yeah, this is what I am doing. We can elaborately discuss later on. Thank you.
Yeah.
Good evening, everyone. I am Srinivas, research scholar working under the supervision of Professor D.M. Singh, and my research topic is methane recovery from hydrate-bearing sediments using CO2 sequestration. And the basic idea is like methane gas hydrates are used resources, energy resources basically found below the ocean bottom or maybe permafrost regions, and we are trying to extract by injecting CO2, which will be an added advantage to sequestrate the CO2 in the form of hydrates, which is very stable for storage of carbon dioxide. So basically when sediments are saturated with these hydrates, how the strength will increase, and also when we are dissociating these hydrate bearing sediments, how the geomechanical properties will change when the conversion of methane hydrate to CO2 hydrate. So here all these geotechnical engineering one principles will help us to understand the geomechanical response of the hydrate bearing sediments.
Particularly the permeability part.
Yes, particularly permeability.
So
and
in CE3, this geotechnical engineering 1, we are talking about hydraulic conductivity.
yes.
Because we assume that the soil mass is fully saturated. But in your case, this is a good example of how gases will migrate through the soils. Though it's not the purview of geotechnical engineering 1, but this is one of the applications. All right? Yes, please.
Yeah, as already Lijit also mentioned, it is also one of the basic multi-phase geomechanical problem. So we can, if somebody is interested who has already registered in this course, the details are there on the website of Professor D.N. Singh. So we can also privately discuss some about the research what is going on in this area.
Correct.
Thank you very much.
Thank you. Yeah, so Mr. Goli, please.
Good evening, everyone. I am Goli. I am a fourth year PhD scholar working under the supervision of Professor D.N. Singh on the topic of characterization and valorization of landfill mine residues as well as industrial byproducts. So we can see through Government of India initiative as well as different schemes that we are mostly into management of municipal solid waste and how to avoid landfills during the course of next 5-6 years or 10 years, and also how to remove the existing landfills is one of the big challenges that current day society is facing. So I am into what are the fractions that are going to generate after landfill mining, what are the properties and how to utilize these properties for different applications, be it agricultural engineering applications or be it civil engineering infrastructure development applications. So this is where, as Professor said, most of the geotechnical engineering applications, we will not consider presence of organic matter in any of the geomaterials. Even if we consider like peats and other materials like seaway sludge as well as other types of sediments, we will not be focusing much and use such kind of materials in civil engineering infrastructure development application. But my work focusing on how the organic matter, which is going to be a predominant fraction of landfill mine residues,
and which we have not considered in conventional geotechnical engineering, because what we do is we eliminate it by doing H2O2 treatment or by heating or by acid treatment and so on. So as you must be realizing that these are slightly advanced topics, but the whole intention of bringing them to this discussion is that you should get a feel that whatever you are studying today under Geotechnical Engineering 1 has a very wide implication and application. Yes. So you are talking about basically man-made soils.
Yes, man-made soils.
All right, artificially created soils, not what nature has given you, what human beings have created.
Yes.
All right, and that's why we also call them as
man-made geomaterials.
Yes, so anthropogenic soil, sediments, and so on. So a lot of implications are there. Yes.
Yes, and apart from this, when we talk about landfill mine residues, one more major fraction will be plastics. If we see the current research trends, everywhere plastic has been treated as one of the major concerns because these are mostly non-biodegradables. So I am into valorization of such plastics which comes out of these landfill mining activities for manufacturing of composites. So civil engineers, like most of the civil engineers, we know about composites in terms of cement concrete. As well as in advanced stages, you will be studying about polymer composites which are fiber reinforced. But I am mostly into particulate reinforced, which are very new in this R&D culture. So therefore, like mostly as a civil engineer, we focus on mechanics of the problem, how failure is taking place in any composite. But material which is going to contribute to the most of the mechanisms, failure mechanisms and all, has been very much less studied. So I am mostly focusing on materialistic perspectives, how polymer composites will be there. Hopefully, we will be able to see our outcomes in near future very soon. Thank you.
One of the philosophical way of looking at this problem is that the soil itself is a composite, made up of several constituents.
Yes.
And what you are doing is you are trying to create a naturally available material which has now depleted, or you are replacing it with man-made geomaterials. In a larger picture, yes please.
Good evening everyone. Welcome to this live interactive session one. And I am Kamran Ilahi. I am working under Professor Singh. I am a first year research scholar, and my area of research is carbon capture, utilization and storage in industrial byproducts. As you will be aware that due to global population growth and rapid industrialization, there are a lot of carbon emissions taking place. And also you will be aware of the recent happenings to promote carbon neutral technologies, like conference of parties that was held in Scotland, Glasgow, in year 2021. So basically the material I am dealing with are alkaline soils. As you will be aware of these industrial byproducts like phosphogypsum, red mud, FGD gypsum, municipal solid waste, incineration ashes, fly ashes. So these are the materials which are highly alkaline in nature, and we consider them as alkaline soils. So they have these sort of problems associated with them. So what we are trying to do is we are utilizing this property of these industrial byproducts, and we are trying to inject the acidic carbon dioxide gas, so in order to neutralize them. And subsequently what we are doing, we are storing this carbon dioxide gas into these industrial byproducts in the form of calcium carbonate, magnesium carbonate, which are very stable in the form of solid forms. So this is the area which professor has given me. So I am working on it, and this is my first year. And hopefully we'll interact on it, and if anybody is interested, he can ask further questions. Thank you very much.
So basically your topic is also an application of a sort of a multi-phase geomechanics, where because of passage of a gas, something is getting either formed, mineralization is taking place, or if the soil is very chemically active or the gas is very chemically active, then there is some sort of a dissolution which is taking place. So you need not worry, in geotechnical engineering 1, we are not talking all those very advanced concepts which we are discussing here, but I'm sure you must be realizing that we are trying to showcase where the subject is heading beyond the copybook style. Alright, and that becomes limitless and worth researching upon and worth enjoying.
Just to elaborate, as Professor rightly mentioned about the geotechnical engineering 1 concepts, so here we are dealing with the static porous media. For example, we are dealing with the hydraulic conductivity. But when we talk about this carbon capture, utilization, storage in the industrial byproducts, here with the chemical interaction happening between these geomaterials and the carbon dioxide gas, their porous media properties evolve. The permeability
Porous
will change.
structure itself is changing.
Yes.
So what he is trying to say is that the pore structure itself is changing over a period of time because of passage of some chemicals. So this is something very interesting. And when the pore structure is changing, all the properties are going to change. Yes, please.
Yes, sir. So here we are trying to study in geotechnical engineering 1, we are trying to study maybe hydraulic conductivity in a saturated porous media. But maybe in these challenging topics, you might be dealing with the partially saturated porous media or unsaturated porous media, where the gas migration will be more important than the hydraulic conductivity. So these are the further advanced applications of the geotechnical engineering 1, which Professor is trying to convey here through this discussion.
Okay, good. Thank you. Yes, please.
Good evening, dear learners. So I am Prithvirendra Singh. I am a second year research scholar with Professor D.N. Singh. So basically, I am working on valorization of waste rubber. So now we can see there is a lot of waste rubber in the form of rubber tires and other applications. How home applications are there where we get a lot of waste rubber. And also there is a crunch of natural materials like natural sands and gravels. So whether we can utilize this material replacing the natural aggregates. And also there comes the concept of anthropogenic geomaterials. Then also there are some other properties of the waste rubber which I am trying to focus on, and whether utilizing this material we can insulate thermal insulation or acoustic insulation. So basically I am focusing on thermal properties of waste rubber and replacing natural aggregates.
So in this geotechnical engineering 1 course, we are talking about only water migration through the porous system. Now, what actually Prithvirendra is trying to do is he is trying to see how heat will migrate. He was trying to understand how gases are going to migrate. He is trying to see how one particular gas can be utilized to replace another gas from the pores. He is trying to see how a gas can be captured in the pores in the frozen form, and by applying different types of pressure temperature conditions, how we can store more and more gases over there. So you must be realizing these are very intricate topics. Yes, please.
Yeah, so focusing on thermal properties. So normally when we talk about thermal properties of material, so most of the studies are focused on only higher temperatures. But what happens in the permafrost region, when there is freezing conditions, or there are certain regions in north side, we see the temperature goes below zero even. So in those conditions, if we using waste rubber, we can provide thermal insulation, then it will be a great success for the society.
So you can create a complete geomechanics of, let us say, waste rubbers. That when waste rubber gets mixed with natural soil, what happens to its properties?
Yeah.
Alright, so another interesting application of converting natural resources and man-made resources into some utility idea. That's what actually you are trying to do. Yes.
Yeah, so basically optimization of the material,
Good.
how much we can use.
Yes, please.
Good evening all, and welcome to this interactive session. I'm Khakira Rashid. I'm working with Professor D.N. Singh. I'm a first year PhD research scholar. My area of PhD is geothermal energy, but not the conventional one where the drilling of the wells is taking place so as to extract this heat that is present in the earth Earth. What is done in what I am working on is that I am making the utilization of already abandoned oil wells where they are not feasible for extracting the oil, but they are in the range of 3 to 4 kilometers depth, so that the heat that is present at the bottom hole that can be mined and with the help of a working fluid. Now, this may seem as not as connected to the geotechnical engineering, but there are a lot of stability issues and geomechanical issues that come into the picture. Like the reservoir, from which we are extracting the heat, where there will be heat migration that is taking place. And if we see it on the microscopic level, there will be presence of oil and water and the reservoir, that is the geomaterial, and the interaction of all these three during this heat migration that has to be studied in order to study the heat that can be extracted, and this is the area that I am working in.
Very good. So this is again a very complicated topic, and I'm sure you must be realizing that all of them are really working on very difficult but so-called enchanting areas. So far in Geotechnical Engineering 1, I'm sure you must be watching these lectures and you must be realizing that what I am conveying in the classroom or through the videos is slightly different than what normal textbooks talk about. Alright. And the reason is because I feel that research in geomechanics is required much more. The reason is very simple. As a civil engineer, we tend to deal with construction of structures which have to be either inside the ground, above the ground, or in the ground. This thing I have covered in the lectures also. So unless you deal with the soil mass or the rock mass or the geomaterials, unless you have understood them well, you cannot really do technology associated with geomaterials. And that is the reason the emphasis in my lectures has been more into giving you the latest of what's happening in the world. And somewhere at the back of the mind, India, I feel that India requires good researchers who can solve our problems which the society is facing. Kamran is from Srinagar, Fakra is from Srinagar, and I'm sure those of you who have visited the cold regions in the country would realize that how difficult life is, including your living as well as conveying water itself, So, though we are in 21st century, we say that we are very civilized, but the fact is that several, people in the country are still not able to get water, clean water, because of the climatic circumstances, apart from the contamination and so on. So this is where actually I am trying to emphasize more. You might find this course a bit different than the other courses, but I hope you will enjoy. Please feel free to write to any one of us emails, and in case you have any doubts, we are here to help you. But please watch lectures carefully and try to go through at least one book which I have prescribed, and that would make your life very, very comfortable. Alright? Yes, please. Now, can we take up the questions which we have received?
So online, like, we cannot see any questions.
Okay.
So in the meantime, we can go through offline questions which we have received. So, like, one student is asking, so he is a faculty at some institute, and he is asking that, sir, which software used for soil modeling?
Yeah, so basically this is an incomplete question. I'm sure you must be realizing that modeling word itself is incomplete. What is that you want to study? What is that you want to model? In case of Legit, you must have heard him, he is trying to model stability of the system when freezing takes place, and under these frozen water, gas molecules are present. Do you want to model this? In case of Srinivas, what he is trying to model? He is trying to model whether carbon dioxide molecules can be utilized to displace methane molecules. And these methane molecules, once displaced, can be utilized for energy. Alright. So what is that you are trying to model? Are you trying to model the permeability, displacement of gases or the fluids in the pores, how the pore structure would be, how compressibility would be, how shear strength would change, how compactability, compressibility will change, and so on. The sky is the limit to model things. So why I am trying to highlight this is that you want to use a software for model something, so that you have to fix. He would like to model, let us say, types of composites which he is creating. What is the porosity of these composites? Okay. Another example of modeling. He will try to see how the neutralization is occurring, how the mineralization is occurring, alright? How dissolution of mineral phase is occurring because of the passage of the gas. Now this also can be modeled, alright? So in his case, like Prof. Singh was talking about, he wants to model whether natural aggregates, both coarse and fine, can be replaced by the waste rubber particles. Alright?
Yeah.
So I want to model it. What will be the response of the waste rubber particles? So this modeling requires stress strain modeling, compressibility modeling, strength modeling, permeability modeling, and so on. How the deformation would occur, how the creep of the particle would occur, and so on. So I am sure you must be realizing that modeling word is incomplete unless put to the right perspective. Similarly, in case of Fakra, she wants to model how much heat can be exchanged from the natural reservoirs of oil and gas which are depleted. Depleted means you have already extracted enough energy out of it. How heat exchange is going to take place. So she would like to do modeling of the heat exchange. Alright? I am sure there is no one software to my knowledge which would include everything in it. Is this correct? So meaning thereby, first please understand what modeling is, why do you want to do modeling, and what is the objective. Anything you like to add to this?
As Professor mentioned, for whichever physical or chemical phenomena we want to model, the governing equations or laws also will be different. So accordingly, we have to select a particular software, or we ourselves can write codes to model it. So we need to be very sure about what physical or chemical phenomena we want to model. Later, we can solve it.
So like in your case, you are dealing with the thermodynamics of the system.
Yes. What I am trying to
enthalpy of the system.
Right.
Is it not?
Yes, yes.
How the energy functions get generated in the system. How the freezing state would occur. Yeah, please.
What I am trying to model is both heat as well as fluid flow. Fluid include water as well as gases, as I mentioned before, methane gas or CO2 gas. So there, particularly in my case, when hydrates are forming, it's an exothermic reaction, and when it is dissociating, it's an endothermic reaction. So there comes the term enthalpy, heat energy releases, and based on that heat energy releases, there will be heat flow happening through the hydrate bearing sediments. And during this entire process, there will be flow of water as well as gases. So accordingly, we have to select different equations, and we have to define in each grid what are the different phases present and what are the heat energy or different components present in it. So for each problem, different softwares or different equations we will have to use. So we have to do some literature initially to find out which software researchers are using and how they are approaching the problem. So that's the important thing.
So here I would like to add this that you cannot do just modeling unless you have understood the mechanisms of the whole process. Alright? Anybody else like to add something?
Like a professor has already mentioned that the response like defines like whatever model we want to do. So whether we want to couple different phenomena like thermo, hydromechanical coupling or any other coupling is there, or we will only like to see the property like slope failure or anything else. So as per the problem statement, like the modeling will also change. It will change from the parameters will change and the influence will also change accordingly. So like you can modify the question and again you can mail your question to us. Then we can answer it more.
So anybody else would like to add something? No, it's okay. Okay. Next question.
Then one question is that I want to study for full geotech for GATE 2023.
See, as I said that you are most welcome to prepare for GATE or whatever. So this, the way I am discussing the concepts of geotechnical engineering 1, my main objective is to create people who can think beyond the subject. Alright. But at the same time, I am sure by doing this course, you will not be in any disadvantageous position, because if you follow the lectures, your concepts will become clear. And if you are following the lectures, doing the assignments and going through some book, I am sure you can do very well in the GATE exam also. This much I would like to say, because GATE questions are also quite, challenging and many times a bit tricky. Start solving as many problems as possible and read the concepts. Do you have any suggestion, anybody, for GATE exam?
You can try solving previous year's questions, and if you're finding some difficulties or doubts you have, you can use Swayam portal also for asking your doubts. We will be there to resolve your doubts there also by after discussing with professor. So in that way also you can prepare well for the GATE.
And for the GATE exam, like you have to clear your concepts as well as you have to solve a lot of numerical questions also. So practice more questions, like first attend the lectures of professor and then try to utilize that theory to solve the problems. So the more you will practice, the more score you can get in the exam.
If I was knowing his background, his or her background, I would have suggested him or her better. But I do not know what is the intention of writing GATE and what is the compulsion for preparing for GATE. Alright, so it's still an incomplete picture for me. I could have guided the person better. So next time onwards, if they are writing their name, that would also be better. Yeah, name and profession, so that we can club the context of the question with your profession or what you intend to do. Alright? So shall we move on to the third one? So Mr. Philanthropist is asking that he has got admitted to NIT Srinagar. Very good, that's a lovely place. And in fact, I have borrowed 2 Srinagar guys from Srinagar to my team in Bombay, Environmental Geotechnical Engineering 11, playing 11. So, well, I would like to get your help regarding choosing my research topic. Research topic is your choice, and your supervisor's choice. I can't say much there, but I don't know what type of help you require, but my suggestion is that come out of this business of depending on anybody. If you are a PhD scholar, you are a PhD scholar, is it not? So it's not a good idea to depend on anyone for your research topic or research ideas, because research topic, research ideas are very personal. Is this correct? What would you like to say, Mr. Kamran? Yes, next time when you are visiting Srinagar and you are visiting Srinagar, Patra, please meet Mr. Philanthropist and then discuss with him over a cup of tea. Better research area. There is nothing known as better and bad research areas. Everything can be a good, you can make very good contributions on any topic. Yes.
I think his name is Manzoor Ahmed Tantre. He is,
Oh, okay, Manzoor Ahmed Tantre. Yes.
So my suggestion will be like knowledge is infinite. If you go in any domain, you can explore more and more, and you can give your full marks. So it will basically depend upon your interest, and also in research you have to also keep in mind the resources which are available with you. So and accordingly you can select the topic of your interest.
So one interesting thing is footmarks you can leave on sands, on clays, and on snow also.
Yes.
So he is getting a chance to leave his footmarks on snow in Srinagar, is it not? And these materials are going to be totally different. So you please understand how the footmarks will become permanent by working in the NIT Srinagar. Okay? Any questions? Yeah, so thank you very much for encouraging all of us by your congrats. You could have included me also in your congrats. Okay, next one.
This question is about Zojila tunnel, sir. So he is asking like Zojila tunnel will not be actually, it will not be helpful throughout the year. So this question is
Like in the long term, like it will not be a successful
Landslides.
landslides and community.
I don't know what is the context of your question, and truly speaking, this type of topic should not be discussed in public domain. It's a good idea to sit down one-to-one and then talk about this, because I am not aware of what the context of the question is, and our idea is not to just speak something without knowing the facts. So either you bring the facts clearly and then we can discuss. Avoid such questions in this forum. First of all, this is a forum where the idea is to multiply further ideas so that a lot of people can do research, is it not? And another thing is just to give you an inside feel into what all is happening and how it can be done. So more technical questions are encouraged rather than personalized questions and project specific questions. Send us details and then ask the questions. Viral Chaudhary, this is over? Okay, thank you. So Viral Chaudhary, why overly consolidate clays when sheared shows negative pore pressure? So this is the part of geotechnical engineering too, is it not? So this, we are having a session for geotechnical engineering 1. Now having said this, it appears that you are a very good student of geotechnical engineering, Viral. So I would like to answer your question. In fact, I would like to ask you a question. What is the peculiar characteristics of over-consolidated clays? Why do we call them as over-consolidated? What happens so that these clays are characterized as over-consolidated clays? The answer comes from consolidation theory. Okay? So you must have realized when you are loading the soil mass in the NC region, normally consolidated region, after that you unload the material, and that portion is known as over-consolidated. Okay? So what's happening here? You have already squeezed out water from the soil mass as much as you could during the normally consolidated part of the curve. Hence, when you are unloading it, the microstructure and grain structure is like this, that it will have a tendency to suck water, and that is the reason why it would show negative pore pressures. Alright? There is a fundamental behavior of the OC material. Stress is less than pre-consolidated stress. What is the meaning of this? Stress, yeah, that's right. So you are answering your own question. Alright, so don't forget that consolidation characteristic curve where you load the system, void ratio decreases, and when after loading to the maximum pressure, you are unloading it, and then it goes back to the rebound curve, or we call this as a swelling curve also, or swelling response also, and so on. Let us be, in my opinion, there are few people at this highest level of learning that engage the student to such level is okay. So, clear. Good, thank you. Okay, next. Any question? So utilize these opportunities of interaction in a better way. This is what I would like to say. Anything which you like to add apart from this?
Like if like those who are like in currently doing BTech, so like I'm giving a suggestion to them only. Like watch the lectures like one time or two times, like up to the time you get a clear idea about the, like try to understand the subject, like basic what is going in the background, and then like you can easily solve any type of numericals. Then like you don't have to ask about like how to prepare for GATE, how to prepare for UC or any other exam. So like when you are going through a lecture, so be concentrated, and whenever like you feel any doubt in any other lectures, so you can use the forum, discussion forum. As like currently we are getting very less questions, like only 3-4 questions in up to lecture number 3 we have received. So I will like suggest you to to ask more questions and generate a discussion in the discussion forum.
See, this subject, Geotechnical Engineering 1, is still evolving. And when I say evolving, every day a new concept gets added up. So it's a very dynamic, I would not like to use the word course. It's a very dynamic system or understanding of the material. So those of you who have watched my lectures carefully, when I was talking about the cause of formation of soil, there I have added a lot of concepts which are becoming very contemporary research topics, which have been ignored so far from the conventional subject. Alright, so if you are watching these lectures, I am sure you get a clear idea about what type of research can be done, what type of research papers should be read. So if you are having interest in this subject and whatever is being discussed in the class, my suggestion would be that you take help from ResearchGate. See who is doing what in different parts of the world. Because in geomechanics, a lot of research is going on all over the world. And people want to hire good students from India because they are very smart, they are very hardworking, they are very intelligent and so on. So get a feel of, relate whatever you are studying in the course with research. That is the future of the subject. So like other subjects in civil engineering, geotechnical engineering is evolving. Alright, anything else you would like to say? Legit?
Nothing much. Maybe this suggestion may not be suitable for BTech or what I want to suggest is that you can go through our professor's web page and ResearchGate profile also. Those who are interested in research can go through his published papers, and there we have introduced more concept about the soil, and you can gain more knowledge also. This is what I want to add.
Yeah, like if you would like to appreciate Srinivas is from petroleum geophysics background, but he is in the geomechanics group, and Goli is from environmental engineering background, and then he is into geomechanics group. So you can realize that geomechanics is becoming a interdisciplinary research-oriented subject. So my suggestion would be, don't study this course just for passing an exam or just clearing the course. Is it not? There is a lot in store for people like you, students, even the professionals, the teachers, and a lot can be done in today's world. Every industry is struggling to solve their own problems. Because each problem in each region has a different component or magnitude of the problem associated with it. Any message for that? Feel free.
Whoever is studying this course, try to clear as much as of your basics, and try to develop a passion for a particular problem that if you are interested in research that you want to forward with. that will be giving you a clear idea of what you will be going to get forward with, and not have to ask what research topic to choose.
Goli?
Yeah, one of the things I would like to convey is, if you go through lectures keenly, as well as Professor Singh's research area, how it is evolving over a period of time, you will understand that right now conventional geomaterials such as sands and gravels, which you are using for construction purpose, are very scarce. So you have to deal with the materials which are unconventional and have not been accepted by the civil engineers previously. For example, sediments, and other examples like industrial byproducts, different waste materials. So these are the futuristic topics wherein not only researchers, over a period of time, even any technologist or any engineer who really wants to work in the development of some infrastructure, etc., has to focus on. So I would say, apart from focusing on basics and fundamental concepts, also take whatever suggestions professor is giving in the lectures and different realistic situation that professor is discussing in the lectures seriously, and try to think on those lines. Therefore, you will be able to have a better understanding and get update yourself with the present day R&D. Apart from these two, and I would like to suggest about PhD, about what kind of topics, one of the students has asked, what kind of topics should be chosen for a PhD. I think more than topic, over a period, the time that you spend in your PhD for 4 or 5 years or 3 years, it's more about learning how to live your next 30, 40 years of life as a researcher, as a professional. So when you start applying, when the process is proper, then you will be able to generate more and more new ideas which are interesting. That's why Professor has also mentioned that there is a lot to do with each and every topic, and beauty of a topic will be explored when you are open to learn from the discussions, as well as when you are able to apply your mind in such a way that the material or the aspect, whatever you are studying, can be uh, uh, can be explored from multifaceted kind of problems. So that's what I would like to say. Thank you very much.
So Srinivas, what is your perspective, being a petroleum geophysicist and an engineering geology person? What is your message to this generation of learners?
Yes, sir. First of all, I would like to add one point regarding the course. Like, you may find so many video lectures, geotechnical engineering 1 courses on our internet, but you will find one interesting thing in this course is, before introducing every concept, professor is giving us some context, basically based on his practical experience of almost 27 years in the field. So he is a practicing geotechnical engineer. So this course is blended with both concepts and context. So you can, if you are not able to understand, you can go through once again and try to understand how this course will help you in understanding the real concepts. And as an engineering geologist, yes, there are a lot of things to do the research in this area, especially reservoir geomechanics. When in geotechnical engineering, if you go very specialized environmental geomechanics, in that again, if you go to the more specific, than energy geotechnics is the current research area, where geotechnical engineers and engineering geologists will help to solve the problems like energy extraction from the deep reservoirs, or greenhouse gases storage in the geological formations, as well as some thermal energy storage. So these are all interdisciplinary in nature. So you can also contact, if you are much interested towards solving a specific problem. That's what I wanted.
Yeah, so that's good, because there was a time when engineering geology was supposed to be no way connected with civil engineering. This used to be an additional subject. But now we are realizing that these are all becoming a sort of a assorted subject and amalgamation of two themes. So porous media remains everywhere. So in geotechnical engineering, what I am discussing in the class and what you are learning is all about the porous media. Now this porous media could be filled up with water, it could be filled up with air, it could be filled up both with water and air, it could be filled up with gases of different types, hydrocarbons, crude oil, or combination of everything, yes. Or even the solid phase could be even minerals plus hydrates, frozen crystals of water trapping air, or some minerals like which are getting formed because of the chemical reaction which is going on. So this becomes a very interesting, and very intricate subject, I would like to say. Like MICP I have talked about in the class. So this is where again the precipitation of calcite is taking place. Now this calcite he can produce by injecting CO2 in a material which has more reactivity. So what nature does and what human beings should be doing, this is going quite parallel to each other. And this is what we are studying in this course. Fine. Anything apart from this? Any other idea? Yes, you wanted to say something?
You have already mentioned about it, about ice and hydrate. Similarly, similar to the formation of solid phase, there can be degradation also happening, which most of the time is problematic also. In the case of
like municipal solid waste. So what you are talking about degradation? Yes, please elaborate it.
So, for example, if you are taking a frozen ground, if there is thawing happening, strength reduction will be happening, and because of it, there will be cracks in the pavement. There can be slope failure happening. So that's some sort of a degradation cost problematicity. And the other problem is about the municipal solid waste, where degradation is happening, and where we have the landfill and it's undergoing deformation, and it eventually causes calamities. So these are some advancements which is happening in geotechnical engineering recently, and which needs to be addressed.
Yeah, so there was a time when municipal engineering used to be different than civil engineering, but now for geotechnical engineers, even municipal solid waste is a porous media. And then we are talking about how easily this whole porous media can degrade, disintegrate, decompose, deteriorate, deform, and so on. So when deterioration is taking place, when decomposition is taking place, there might be a situation where multiple phases of the matter are getting generated. Residues are solids, leachates are gaseous, semi-solid, fluids, and so on. So the realm is becoming very big. So there is only one way, you can only enter into it. There is no exit. One life is left to exit from geotechnical engineering circle. Thank you. Thank you very much. Bye-bye. Any other question before I close this discussion? I think we don't have any questions. Viral Chaudhary, I wanted to ask for logical explanation for why cohesion is 0 for normally consolidated clays, whether it is UU or CU. So Viral, my suggestion is, because this is not in the domain of geotechnical engineering too, because learners would get confused. Do not ask a question which is related to the second part of the course, but I would like to answer your question. Why cohesion is 0 for normally consolidated clays? What could be your answer? Whether it is CU, CD or UU, what could be the reason? It's a slurry, alright. What is the NC material? It's a slurry. So if you load it a bit, what is the shear strength? 0. Correct? In case of sands, what happens? It's a reverse process. So sands, if you make a slurry and put it in a bottle, and if you shake it, you hear a lot of noise, friction. So there only friction will get mobilized. So these are the inherent properties of the materials. Anyway, please take up course in geotechnical engineering to understand fully. No, you need not do sorry, but it's okay, fine. I know that you are very anxious to learn. Okay, we will keep on discussing this. Saurabh Jadhav, what are the career opportunities in geotechnical engineering? I think you should tell me what should be my career further. So then I will act accordingly. Thank you very much. You should be giving me a challenge that I should be doing this further, and then I will learn more and I can teach more. Thank you very much for your good questions, and keep it up. Done?